Okay, let's start with the simplest one, range. So the range is the simplest measure of dispersion and represents the difference between the maximum and minimum values in a dataset. Range can be calculated by subtracting the minimum value from the maximum value. So the formula is range equals maximum value minus minimum value. For example, if you have a set of data points like 2, 5, 8, 12 and 15, the minimum value is 2 and the maximum value is 15, and the range would be range equals 15 minus 2 equals 13. So in this case, the range of the data set is 13. The range provides a quick indication of how spread out the values in a data set are. The next one is variance. In statistics, variance is a measurement of the spread of numbers in a data set. It measures how far each number is from the mean or average and from every other number in the set. So mathematically, the variance is calculated as the average of squared differences between data point and the mean. Variance provides a more comprehensive measure of how spread out the values are. However, because it involves squared differences, the resulting unit is squared, making it less interpretable than the original data.
Standard deviation. Standard deviation is the square root of the variance. It is the measure of how spread out numbers are. To calculate the standard deviation, we must first calculate the variance, and then take the square root of the result. Actually, standard deviation is one more useful measure than the variance, because the standard deviation is in the units of the original dataset. So, there are two formulas to calculate the standard deviation, one for a population and one for a sample. The sample standard deviation is denoted by S and is calculated by using this formula. And then, for the population standard deviation is denoted by sigma and is calculated by using this formula. Here, X represents the individual data points, mu is the population mean, X bar is the sample mean, and N is the number of data points. Let's see the example. Mean deviation. Mean deviation is a statistical measure that calculates the average deviation from the mean values of a given dataset. It is a measure of how far the value in a dataset are from the middle of a given dataset. Here, the formula of mean deviation, where sigma is summation, X is observation or values, and mu is mean, and N is the number of observation. There are three steps to calculating the mean deviation. Step 1. Find the mean of all values. Step 2. Find the distance of each value from the mean. Subtract the mean from each value and ignore the minus signs. And last steps, find the mean of those distances.
Absolute deviation serves as a valuable metric for quantifying the dispersion of spread within a set of data points. It provides insight into how much each individual data point deviates from the central tendency, typically represented by the mean. The process of calculating absolute deviation involves a series of steps to capture the extent of variability in the dataset. To begin with, the deviation of each data point from the mean is determined. This deviation is expressed as the arithmetic difference between the specific data point, denoted as X, and the mean of the entire dataset, represented by the symbol mu. The mathematical expression for this deviation is given by X minus mu. However, merely calculating deviations would result in a mixture of positive and negative values, potentially canceling each other out when summed. To avoid this, the absolute value of each deviation is taken. The absolute value ensures that all deviations contribute positively to the overall measure of variability, irrespective of their direction from the mean. Once the absolute values of deviations for each data point have been determined, the next step involves summing up these absolute values. This cumulative sum provides a single, comprehensive measure of the absolute deviation for the entire dataset. In other words, it encapsulates the total magnitude of differences between individual data points and the mean. By examining the absolute deviation, one can gain a better understanding of how widely dispersed or tightly clustered the data points are around the mean. Larger absolute deviations indicate greater variability, while smaller absolute deviations suggest a more concentrated distribution. This metric proves particularly useful in statistical analysis as it offers a quantitative assessment of the data's overall spread, aiding in the interpretation of patterns and trends within the dataset. Sigma notation, denoted by the Greek letter sigma, is a shorthand notation frequently employed in mathematical and statistical contexts to succinctly represent the summation of a series of values. This notation is particularly valuable when dealing with extensive datasets or intricate mathematical expressions, offering consistency and efficiency in conveying complex ideas. In sigma notation, a series of values is expressed by writing the symbol sigma, followed by the expression to be summed, along with specific limits indicating the range of values to include. The lower limit of summation is typically indicated at the bottom of the sigma symbol, and the upper limit is placed above it. The expression to be summed is written to the right of the sigma symbol. This compact representation simplifies the presentation of mathematical formulas that involves the summation of numerous terms. It provides a convenient way to express concepts such as the sum of sequence, the total accumulation of data points, or the aggregation of values according to a specified pattern.
Okay, next, move on to the useful check. In a symmetric distribution, deviations or differences of data points from the mean are balanced on both sides. This means that for every data point above the mean, there is a corresponding data point below the mean, and the total deviations on one side should equal the total deviations on the other side. Let's see to the example. The data are 3, 6, 6, 7, 8, 11, 15, and 16. So the derivation are for the left side 6 plus 3 plus 3 plus 2 plus 1 equal 15. And for the right side 2 plus 6 plus 7 equal 15. So we can conclude that the deviations from the mean on one side balance the deviations on the other side, making the distribution symmetric. This balance is reflected in the equality of the sums of absolute deviations on either side of the mean.
For the next material is coefficient of variation. The coefficient of variation, or CV, is a ratio of the standard deviation to the mean or average. For example, the expression the standard deviation is 50% of the mean. This is the coefficient of variation. The CV is particularly useful when you want to compare results from two different surveys or tasks that have different measures or values. For example, if you are comparing the result from two tasks that have different scoring mechanism. The formula for the coefficient of variation is coefficient of variation equals in bracket standard deviation slash mean multiple 100. In symbols, we can write it like CV equals to in bracket SD slash X bar multiple 100. Multiplying the coefficient by 100 is an optional step, to get a percentage or as opposite to a decimal. Next is coefficient of variation example. A researcher is comparing two multiple choice tests with a different condition. In the first test, a typical multiple choice test is administered. In the second test, alternative choice, for example, incorrect answer, are randomly assigned to test taker. The result from the two tests are mean for regular test is 59.9 and for randomized answer is 44.8, and for SD in regular test is 10.2 and SD in randomized answer is 12.7. Trying to compare the two test result is challenging. Comparing standard deviation doesn't really work because the means are also different. Calculation using the formula CV help to make sense of the data. So we can get CV for regular test is 17.3 and CV for randomized answer is 28.35. Looking at the standard deviation of 10.2 and 12.7, we might think that the tests have similar results. However, when we adjust for the difference in the means, the results have more significance. Like regular tests, we have CV 17.03 and randomized answer, we have CV 28.35.
The next material is about index of quality variation. The index of quality variation, or IQV, is a statistical measure used to gauge of extent of the data dispersion within a distribution. In the context of descriptive statistics, measures of dispersion, such as IQV, help us understand the spread of data around the central or mean value. IQV is obtained by defining by interquartile range, or IQR, by the mean. IQR is the difference between the upper and lower quartiles of the data. A higher IQV value indicates greater variation in the data distribution. However, it's worth noting that IQV is not commonly used as other measures of dispersion like standard deviation or range, and the choice of this metric depends on the specific statistical analysis requirements. For the example, IQV equals K bracket 1000 square minus sigma PCT square bracket divided by 1000 square bracket K minus 1 bracket, where K is the number of categories and is the total number of cases in the distribution. Sigma PCT square is sum all of square percentage in the distribution. The next material is how to choose a measure of variation. How to choose a measure of variation depends on the characteristic of your data of the specific insight you seek. Different measures of dispersion provide different perspectives on the spread of data. The first is a range. Simple measure but sensitive to extreme values, suitable for a quick overview but might be affected by outliers. The second is interquartile range, focuses on the middle 50% of the data, making it less sensitive to outliers than the range. The third is a standard deviation, provides a more precise measure considering each data point's deviation from the mean, suitable for normal distribution. The fourth is a variance, the square of the standard deviation, useful when a more sensitive measure is needed.
And last is a coefficient of variation or CV, useful when comparing the relative variability of datasets with different units or scales.